Welcome to this session. In this session, we discuss how to find inverse of a square matrix by adjoint method. So we start by defining what we mean by an inverse of a square matrix, and then we'll do an example. So definition. So if A and B are square matrices, remember inverse can only be defined for square matrices, are two square matrices of the same order such that A times B is the same as B times A, and this product gives an identity matrix, then B is called the inverse of A, i.e. B equals to A inverse, and A is the inverse of B. So this to say A is B inverse. So this is how we define inverse of a square matrix, that we need to have another matrix. So inverse of a matrix A is another matrix B of the same order as A, such that when I take A times B, it's the same thing as multiplying B by A, and I get an identity matrix. So the condition for square matrix to have an inverse is that for square matrix A to have an inverse is that A must be non-singular that is, the determinant of A must never be 0. So that's the condition, that if the determinant of A is not 0, then the inverse exists. But if the determinant is 0, then there is no inverse. So a matrix which has a non-zero determinant has an inverse and is said to be invertible. So whenever the determinant is non-zero, then we are assured that there is an inverse, and we say that that matrix is invertible. So to find the inverse of a square matrix A will follow the following steps. So the first step, find the determinant of A. Of A. So if determinant of A is 0, stop. The inverse of A does not exist. But if determinant of A is non-zero, then go to step 2. The first step, find the determinant. If the determinant is 0, the inverse does not exist, so you don't have to proceed. Number 2, find the cofactors of every element of A and form the matrix of cofactors for A. Say, or call it C, that's the matrix of cofactors of A. And then number 3, once you have the matrix of cofactors, find the transpose of the cofactor matrix obtained in 2 above to form adjoint matrix. I.e., the adjoint of our matrix A is given by the transpose of the cofactor matrix. And then number 4, which is the last step, the inverse of A is the product of the reciprocal of determinant of A and the cofactor matrix and the adjoint matrix of A, i.e., A inverse is equals to 1 over the determinant of A times the adjoint of the matrix A. So those are the steps we follow whenever we want to find the inverse of a square matrix A. Now let's do a problem. will say that appetizer. So given that A is this matrix 3 minus 3, 4, 2 minus 3, 4, 0 minus 1, 1. Find A inverse. So this is the problem. Now we say that the first step, you have to confirm whether the inverse exists or it doesn't exist. And you know if the inverse exists or it doesn't exist, depending on the value of the determinant of the matrix. If the determinant is 0, then inverse doesn't exist. If the determinant is non-zero, the inverse exists. So step 1, determinant of A. Now we can expand by cofactor method using the first column because at least we see a 0 here. I remember this is usually plus, minus, plus. So it's the same as 3 times the submatrix minus 3 and then minus 1, 4, 1, minus 2 times, and then delete this. So we have minus 3, minus 1, 4, 1. And this being 0, then we don't have to write it. So this will be 3 into minus 3 minus 4, so it'll be plus 4, minus 2 into minus 3 plus 4. So we'll have 3 times 1 minus 2 times 1. So we get 3 minus 2, which is 1. So since determinant of A is 1, i.e. determinant of A is non-zero, then A has an inverse. Now we have this matrix A given by 3 minus 2, 4, 2, minus 3, 4, 0, minus 1, 1. So the next is to find the cofactors. So cofactor matrix given by C11, C12, C13, C21, C22, C23, C31, C32, C33 is given by, now you simply remember the sign pattern. So this plus, minus, plus, minus, plus, minus, plus, minus, plus, and then take the sign of every element times its minor. So starting with the first one, the sign here is plus. So it's simply the cofactor here will be the determinant of this submatrix minus 3, 4, minus 1, 1. So it will be minus 3 times 1 is minus 3, minus 1 times 4, we get 1. So here we'll get 1. And then next will be this one here. The sign is negative, so close this and close this. 2 times 1 is 2. So 2 minus 0, we get 2. But the sign is negative, so you have to attach minus. And then here, sign is plus, close this, close this. 2 times minus 1 is minus 2, minus 0, so minus 2. Sign is plus, so minus 2. And then this one here, so close this, but the sign is minus. So this minus 2, and then we'll have, so remember we have closed this and deleted this. So deleting this and deleting this one here. So we remain with minus 2 times 1 is minus 2, minus minus 4, so that is positive 2, but the sign is minus, so we'll have minus 2. So just a minute here. When I delete this, I delete this, so I'll have minus 2, 4, and then minus 1, 1. So I'll have minus 2 times 1, I have minus 2, minus minus is plus, so 4. So this will give me positive 2, but the sign here is minus, so I'll have minus. That's fine. So I'll have minus 2. And then here I have so minus 2, so this is so 3, 2, 0, minus 3. Oh, this was supposed to be minus 3, not 2. Oh, this is minus 3. Sorry. This element is minus 3, not 2. So which means now we'll have minus 3 times 1 is minus 3. And then, so minus 3 and then plus 1, so I have 1. Yeah, so this will be negative 1. It should be negative 1. And then this element here, we'll have delete this and delete this one here. So we'll have 3 times 1 is 3. And then 4 times 0 is 0. So 3 minus 0 is 3. Sign is plus. So just get 3. And then here, delete this. So we'll have 3 times minus 1 is minus 3. And then 0, we get minus 3, but the sign is minus, so we get plus. Delete this, so minus 3 times 4 is minus 12. And then 3 times minus 4 is minus 12, minus minus is plus 12. So this will be 0. And then here, delete this column, this row. So I'll have 3 times 4 is 12. And then 4 times 2 is 8. So 12 minus 8 is 4. But the sign here is minus, so I have minus 4. And here, delete this column, delete this row. 3 by minus 3 is minus 9, minus 3 times 2 is minus 6, minus plus. So this will give me minus 3 times plus 1 gives me minus 3. So which tells us that the adjoint of A, which is the same as the transpose of cofactor matrix, will be given by 1 minus 2 minus 2 minus 1 3 3 0 minus 4 and then minus 3. So that's what we have. So which means by definition the A inverse is 1 over the determinant of A times the adjoint of A, which will be 1, determinant was 1, into 1 minus 1 0, minus 2, 3, minus 4, minus 2, 3, minus 3, and 1 over 1 is just 1. So therefore, the A inverse is just the matrix 1, minus 1, 0, minus 2, 3, minus 4, minus 2, 3, minus 3. So that is the inverse of that given matrix. And you can always confirm that if you take A times A inverse, the same as A inverse times A, is an identity matrix. Please confirm that. So that is how we find determinant for this given matrix A. Thank you.